Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 257. Ooh, yikes. GCD sort of an array. So basically, this is a tricky problem. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about this problem. Especially if you'd like to talk about this and other problems. Come hang out. Come make me feel good. In like conversation. I don't know if that sounds like I'm trying to brag or something. But yeah, so this one, I actually got it relatively quickly. I got it in about 13 minutes. And if you watch me solve it live during the video, the live coverage, I actually talk way too much. I probably could have, if I just focus on coding, I probably could have done it much quicker. But I don't know. Maybe today I'm just in a talkative mood and I didn't care about it that much. But yeah, I didn't get a wrong answer, so that's good. I wasn't even confident anymore because I've been very sloppy. But the idea here is this, right? So basically, you can sort two numbers if there's a common divisor. So I'm going to break it into two components. One is, we'll do about the primes part. But basically, let's say pretend that, I know that n is 10, is 3 times 10 to the 4th, but because n is 3 times 10 to the 4th, we cannot do this in n squared time because it takes too long. But let's pretend that we can do this in n squared time. Then I'm going to explain an n squared algorithm real quick, right? And this is maybe intuitive if you think about it. I don't know what the sorted thing is. Okay, I can copy and paste. But yeah, I'll go over a couple of cases. But the idea is that if you have an n squared solution, then you can look at every number, every pairs of number, and kind of see if they have a common divisor, right? If they have a common divisor, then you can sort between them. And in this case, for example, 5 you could sort with 10, and in a way, because of this, what's it called? They call flipping, swapping. In this case, swapping is transitive, right? And what do I mean by that? What I mean by that, if you can swap A with B, that means that, and you can swap A. Okay, let me say it again. Let me write it down. If you can swap A with B and swap B with C, then you can swap A with C, right? I don't. My computer's a little bit slow. And the reason why this is the case, even though you cannot do it directly to be true, right? So for example, let's say you have A, B, C, and you want to sort it backwards, and you cannot swap directly A with C. You can just kind of use, you could kind of use B as an intermediate variable. For example, this is one possibility. You sort A with B, and then you sort C with B, and then you sort C with A, right? Or sorry, B with A. So you can definitely do it. So even though it takes a couple of operations, but because we have infinite number of operations, this transitive probably holds, right? So that means that now, if we have an n squared algorithm, is that, well, now we just kind of go through the array to kind of do a depth first search on every possible pair, right? And what I mean by depth first search is that you may imagine that we have, now instead of A and swapping B, then now A is connected to B. There's an edge from A to B, and there's an edge from B to C, and that means that those three numbers are interchangeable with each other, right? And then now you can do a connected component. And what does that mean for you? Well, in this case, at the very end, there are a couple of scenarios, right? Which means that if the final sorted numbers, if you look at them one by one, if they're in the same connected component, then you can get them together, right? In this case, in this case, actually, I think every number is sorted, but okay, they don't provide a good example for you. But for example, you can imagine something like 2, 4, or let's just say 4, 2, and then we add some odd numbers, 3, 9, 27, right? Okay, maybe a little bit not sorted. So let's just say, I don't know, 9 again, right? Doesn't matter, right? So the idea here is that we're building out these components because, okay, we know that we can swap this number with this number, right? So this is one component. So one component is 4, 2, and then another component is 9, 3, 27, right? Because you can swap them with each other. And then now, if we're given the sorted answer, the question is, okay, so can this 4 get to this 2? Well, the 4 can get to this 2 if they're in the same component, right? And you can do this in n square. Of course, it's times out, but the depth first search or breadth first search will be n square, right? Yeah, the 9, can you get to the 3? The answer is yes. Okay, that's good. The 2, can you get to the 4? Yes, because they're in the same group. Same for 3 and 27, right? So then the answer is true for this one. But keep in mind that in this case, the 4 and the 2 do not interact in any way. Oh, sorry. The 4 and the 2 interact with each other, but they're totally independent from the 3, 9, and 27, right? So that's one thing. And then the second thing, so that's the n square algorithm, and that's too slow, right? So then the question is, how do you make it faster? Well, the thing that I talked about is connected components, and that should ring a doorbell. And the doorbell is use union find. And basically the idea behind union find is that, okay, for every number, this is not a good example, but for every number, we try to figure out, so for every number, you can still do it n square, but the linear time way is to break it down to each components, right? Because, okay, for example, and this is kind of awkward because these are all powers of whatever, so let's actually take this number real quick. Right? So what does this mean? This means that 10 is equals to 2 times 5. What does this mean? That means that this number is in the same group with every multiples of 2 and 5, or and every multiple of 5, right? So now, right? But what does this also means, right? This means that 10 now is a group between 2 and 5 because of what we said earlier with the A swap B equals B swap C and so forth. So the transitive property holds, and that means that, now given the 10, even if you have a 2 and a 5, let's just say we have 2 and then a multiple of 25 and 4, say, right? Or even 5 times, say, 9, so 45, right? So 45 and 10, they have at least 5 as a multiple together, or sorry, a divisor together. So that means that you can swap 45 with the 10. And then because 10 is also as a divisor with 4, that means that 4 now can swap with 45 due to the transitive property, right? But so what does this, now I'm going to say it another way. This means that now any number with a divisor of 2 is now swappable with any number with a divisor of 5. I think I mistyped it because I can't see what I'm typing because my computer is slow for some reason. My Chrome is slow. Okay, actually I mostly typed it okay. So swappable is 1p, I think. Is it 2p's? I don't know actually. Whatever. So yeah, so that's basically the union find way of doing it. Is that now now you in this way so now you define these what they call equivalent set. So now you have multiples of 2 and as in one set, and multiples of 5 in another set, and now you put them together, right? So that's basically the union find solution. And now, yeah, the thing that I thought about though is that this may still not. So this is fast. You could do this in linear time. The problem is that you have to factor every number in the number list, and that maybe too slow if you're not slick enough, right? So the way that I did it, because you can do some math, so the biggest number is 10 to the 5th, so the square root of that times 30,000 is equal to some number. I forget what it is, but it feels too big. Is this fast enough in Python? Yeah, so I wasn't sure, so I did one more optimization, and the optimization is using the sieve. I always forget how to say the sieve of Aristoteles. Did I spell that right? Nope. Close. Mr. T. Maybe I misspelled this right. I misspelled this incorrectly. How do I spell it? Toast. Yeah, okay. Eratosthenes. Okay, well, but yeah, so I would Google this, but basically that's the way that I did it. I'll go over my code right now. Pretending that union find is constant. I know that there's some inverse argument stuff. I know, but I'm just going to call it constant for now because it's easier to say. So I have these this union find code, and then now I have. So I set up the primes. This is the sieve. Basically, I just go up to the max, and max is the biggest number into the array. But basically, I calculate all the primes factors for this number. So and this is just the sieve. I'm not going to go over the sieve that much, but this is actually max. Let's say m is equal to max. This actually wants m log m time. The proof is a little bit tricky. Please do some research. But yeah. But basically here, now that we have all the primes together, we union them with the first one because that's just how you group them. Is transitive, right? So now we union all the primes together given a number, and then at the very end, this is just to see if they're in the same component, which is that, okay, if the ufind of the number, so s nums is the sorted number, so we have to sort it, so it has to be n log n, I suppose, actually. But basically, we look at if the number in unums, if the group is the same as or if it's not the same, then that means that it's false. Otherwise, if it's true for every one of them, then it's true. So yeah, so this algorithm, like I said, because you have to sort first, it's going to be n log n plus m log m, where m is the max number. Yeah, in terms of space, this is O of I think m log m as well because of this thing, because yeah, and also O of n plus this for space, because this can contain a lot of devices, I think. So I think it's m log m. I could be wrong on that particular one. Yeah, and there's also a lot more space for union find and stuff like that. But yeah, but that's all I have for this one. Let me know what you think. I think if you get this part, you can actually implement most of this part. The sieve is also a little bit tricky as well, but that's fine. I actually did everything from scratch. I didn't do any copy pasting. I know that people like to have this as template and even this as template, so maybe you can save a couple of minutes. But yeah, I did this in about 13 minutes without it, so you should be able to not need it, is my point, even if it takes longer, obviously. But yeah, that's all I have for this one. Let me know what you think. And you could watch me solve it live during the contest next. And I talked a lot during the contest, so hopefully maybe that's helpful. I don't know why I talk so much. Anyway, ta-da. Let's actually see how this one's looking. 47 people have gotten it, so if I do this now, maybe I'll get in a good time. But yikes, though. That was a rough problem for me. Okay, but I just need to write it down. Actually, after I wrote it down, it was pretty easy. But I just kind of convinced myself I didn't need to. Okay, let's actually do this one. Any number of times, swap I and j if they are whatchamacallit, if they're mutually something. I'm blanking out the numbers right now. Return true if it's possible to store numbers in non-decreasing order. Okay, so basically this is going to be some sort of union find, perhaps, and this kind of thing. Okay. So yeah. How do we figure out? Though? I think it's gonna be some sort of union find, but how do we figure it out? If they have a common denominator, or common divisor, then that's good. So that, well, that means that we can do them. This is 10 to the 5th, so common dividers are not that big, but that means that for every, we can group. Okay, so we just factorize every number and then we group all of them. And if we are able to group all of them, I mean, but that's not always true, because in that you can have to, if the input is already like sorted like this, it doesn't matter that they're not grouped. So then the question is, okay, I see. So then now it's just union find, and basically for every, we just look at the group of the result and the thing. Okay, fine. So sorted array, or sorted answer maybe? Sorted answer is equal to a copy of this, or we just sorted actually. Let's go to S nums for sorted nums. And then now we factor every number, and okay, so then union find. Okay, union find. Do 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 do. How do I do union find? Okay, union find of x is equal to return parent of x, and then here, if parent of x is not equal to x, parent of x is equal to find parent of x. Okay, and then here we just have parent is equal to this thing. It's not even maybe call it group. I forget what I use for union find. Let's call it G. Let's call it parent, whatever. I know what that means, and that's good enough for me. A is equal to u find of a, up is equal to u find of b, parent of ua is equal to up, and then that's pretty much it. So then now we group them together. All the numbers for x and nums, we factorize. How many numbers are there? 30,000, is it? 3 times 10. I always forget. I read this as sometimes 3,000 and I get in trouble. So okay, 30,000 square root of 10 to the 5th. What is square root of 10 to the 5th? Square root of that. I'm just using a calculator, don't worry. It's 316, so 316 times 30,000 is 9 million. Yikes. Is that fast enough? I'm trying to think how I would write this in a good way. Do I need to use the sif? I'm worried about just doing this straight up, but then this goes only up to 10 to the 5th, so we can use the sif. Yeah, let's do that. Yeah, okay. Let's see what nums. Let's write the sif. Okay. The good thing is that we can able to test this pretty quickly, so that's good. Okay, what does that mean? I have to remember how to do the persive, but I should be able to do this. This 45 minutes, and I think my idea is right. My implementation's just been terrible because I don't practice enough. But okay, if length of primes is equal to 0, that means that this is prime. So prime sub x. Well, this is a prime. So then, okay, just do this, and then otherwise. And then we do for I in range of, let's just do it this way. While y is less than or equal to max, we add this by x. And then we just do prime of y dot append x. Okay. Yeah, okay. So then now let's return something. Let's see if this should be fast enough. I'm going to run it for this, but what I really want is something like 10 to the 5th. Do I have enough zeros? Or it's hard to tell. Oh, 2 and that. Okay, fine. Okay, this looks fast enough, so I'm happy about that. Let's print it out real quick to see that we do real work, because otherwise. Okay, so we don't do real work, so that makes it easier for it to be fast. Huh. Oh, okay. That's why it was just a quick loop. Okay, y is equal to x plus x. Okay, so this is fast enough, maybe. We could, if it gets nasty, we could mess it up. But 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Everything looks okay so far, and it runs pretty quickly. So okay, so then now we have the lookup table for the sieve. Then now we just have to go for the x. Okay, for x in nums. So what does this mean when we see a number? Let's also get the index. When we see a number, it means that we want to group all the things together. So okay, for y in primes sub x, we want to union y with primes of x of 0. So this should be a union. We'll start actually from the first number, so then we skip the first number. Yeah, maybe this should be good. So then let's look at parents. Oh, I forgot to set this to, how do I want to write this? Okay, if x is not in parent, then parents of x is equal to x, and then we return. Okay, maybe that's good enough actually. Okay, it doesn't. So then now it's what am I printing? That means that 2 and 5 are in the same group, which is what we want. 2, 5, and 3 are in the same group, so that's also what we want. Is that a true answer for the second to last one? 5 cannot be I thought we put 5 in the same thing. Okay, so maybe that's not quite true. Let's see. Let's print out what I'm doing here. Print out union so x of 0 and then y. Okay, so it's union 2 and 5 and then 3 and 5. Why? Am I looking at the right case? Oh, I'm looking at the wrong case. That's why. Okay, sorry. So okay, so I am doing it right. And then here it doesn't because 2 and 3 unions, but then the 5 doesn't. Okay. So then now we are mostly done. All we have to do is just Yeah, okay. Actually, we don't even need the index on here, because this is just to include the unions. And then now we look at for AB in SIP of S nums and S nums, if union find of A, that's not true. What am I doing? If the union find of the prime sub A of 0, basically get the group that it is in, and we union everything, so everything should be together. If this is not equal to that of B doing that, then we return false. Otherwise, they're in the same group, so we're okay. I think I talked too much, to be honest, but okay. So this looks okay. I mean, I'm a little bit early, but let's give it a submit. And then if we get a wrong answer, we'll debug it. Cool. I mean, I was actually pretty happy about this one. Hey, yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord, and come hang out with me. Yeah, stay good, stay healthy. Hope you have a great rest of the week. Hope you had a great contest. Anyway, see you later, and yeah, to good mental health. Bye-bye.